Okay, we got a new parent function called the exponential function. F of x is equal to a times b to the x minus h power plus k. Like usual, a controls vertical stretches or squeezes, and it also will control reflections over the x-axis. H controls horizontal shifts left and right. K will handle vertical shifts up and down, and also exponential functions are going to have an asymptote. So it'll be y equals k. The b, the base, is also going to tell us whether it's exponential growth or exponential decay. Now, if it's between 0 and 1, it's going to be decay because it's going to get smaller. So think of like 1/2. When I square 1/2, 1/2 times 1/2 is a fourth. And then if I raise 1/2 to the third power, that'd be 1/2 times 1/2 times 1/2, that'd be 1/8. So it's getting smaller, so we'd have a decay, and you can see that it's going down. If b is greater than 1, for instance 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, you see that it's growing. So the base will tell us whether we're growing or decaying. Okay. So let's go ahead and take a look at the next page. So we're going to go ahead and graph one function here. It's going to be f of x equals 2 to the x power. And then usually what we do is we pick, here I got 7 values, maybe 5 values around 0 to kind of get an idea what the graph looks like. So to the 0 power, anything to the 0 power is going to be 1. 2 to the, and I'll go ahead and plot that point in. 2 to the first is going to be 2. Go ahead and plot that point in. 2 squared is going to be 4. And 2 cubed is going to be 8. So we'll plot those points in first, and then we'll handle the negative exponents. The negative exponents here are going to give us reciprocals. So 2 to the minus 1 is the same thing as 1 over 2 to the first, or 1/2. I'm going to plot that point. 2 to the minus 2 is the same thing as 1 over 2 squared, which is a fourth. And 2 to the minus 3 will be 1 over 2 cubed, or 1/8. And then we'll go ahead and plot those points. If you need a minute, you can just pause the video and plot all those points in. Now we have a horizontal asymptote of y equals 0 because 2 to any power is always going to be positive. It might be like really small or really big, but it's always positive. So we're not going to get any negative outputs here. So we do have a horizontal asymptote of y equals 0. And if we do 2 to the negative 10, that'll be 1 over 2 to the 10th power, which is going to be way small. So the further we go off to the left, we're getting closer and closer to 0. So we do have a horizontal asymptote, and our function is going to look like this. So in this one, we have end behavior where we flatten out in only one direction. So unlike the rational functions, we kind of flattened out in both directions. We're only going to flatten out in one direction in this case. Okay. And then I'm going to do a one reflection of this. So if we look at 2 to the minus x, that minus in the argument is going to reflect it over the y-axis. So then we can go ahead and use the y-axis right here. Use this y-axis. Let me highlight it as our mirror. So then we have folks looking at each other in the mirror, and that'll help us with that reflection. So if you have a negative x in the argument of a function, that's going to reflect it over the y-axis. Okay? And go ahead and label our graphs too. Alright? For this next example, I'm going to first draw in our parent graph again, the 2 to the x. then we're going to do a reflection of this. Okay, so if it's with the x, if it's a negative x, that's going to reflect it over the y-axis. If it's a negative in front, that's going to reflect it about the x-axis. So we're going to reflect it about the x-axis. So we should have mirror points here, here, somewhere down here, and somewhere down here. So we have a mirror function just like that. So we're going to reflect over the x-axis, and we'll go ahead and reflect each one of those points. And you notice that they both have the horizontal asymptote y equals 0. So all we did is we reflected the blue line, or not the blue line, but the blue graph over the x-axis. So that's our reflection. Now if you can graph the 2 to the x power, you know how to do reflections, you know how to do shifts. So what you really need to know is how to graph y equals 2 to the x. That's just plugging in some values in for the x and finding what the outputs are, plotting those points. Then you can do the reflections and translations. Alright. So I'm going to go ahead and graph in our parent function again. And then we're going to do a translation. So it's with the x, the -1, that's going to control horizontal shifts. So if it's x minus 1, that's going to be a horizontal shift to the right 1 unit. So all we got to do to graph this is we need to move each one of these points over to the right one. So move each one of those points over to the right one, and we have our graph. So that wasn't so bad. Okay, and now we'll do another shift. Okay, now we got the -1 here. That's not with the x, so that's going to control vertical or horizontal shift. So that's going to actually shift it down 1 unit. I'm also going to mention that our horizontal asymptote for the first two folks, for the orange and black, these two, was 0. Now that we're shifting vertically down 1 unit, that's also going to shift my asymptote down 1 unit for this function. And our horizontal asymptote will now be -1. Okay. Now for my points, I'm going to shift the black dot down 1, shift the black dot down 1, black dot down 1, black dot down 1, and there we have it. Not too bad. Alright. Well, let's do another one. I want to graph the inverse function. Let's see what the inverse function would look like. Okay, so I'm making the same table that we did on the first graph of our parent function. Now the inverse, remember, just switches the x and the y. So we're gonna make our table, switch the x and the y, and I don't have a name for f inverse yet. We don't know that yet, but it's going to be called a logarithm. But it just switches the x and the y for the inverse. So all our x and y points are just switched. And I mentioned that my asymptote for my parent function is 0. Since we're switching the x and the y, my asymptote for my inverse, the x and the y switch, so I'll have x is equal to 0 as an asymptote. I'm going to go ahead and graph in my parent function like I did before. And then using my points, I'll go ahead and mention my vertical asymptote is 0 because we switched the x and the y for the function and its inverse. And then I'm going to go ahead and plot my points. Okay. And remember, I also said it was a reflection over the line y equals x, and you see we have a nice reflection over the line y equals x. And depending on how good of an artist you are, you may get a pretty graph. Alright, I figured I'd do one more example with a exponential decay. So we're going to look at an exponential function with a base of 1/2, and we'll kind of play the same game. I'm going to use the points -3 through 3. Okay. Now when I do the negative exponents on a fraction, that just flips the fraction over and the exponent becomes positive. So it becomes 2 cubed, which is 8. So it just flips the fraction over, the exponent becomes positive. That's one of our exponent rules. And then anything to 0 power is just 1. Alright, now for the positive exponents, 1/2 to the first power is 1/2. 1/2 squared is a fourth. 1/2 cubed is an eighth. And then we'll go ahead and plot those points. And you see that we have decay. It's decreasing. And it has an asymptote of y equals 0. Alright, so the base is going to tell you whether you're growing. So growth looks like this. Decay looks like what we have right here.